Very good morning, students. Welcome back to SPR online classes. So today we are starting bridge course classes for 10th standard students, right? So the first topic what we are conducting is what coordinate geometry. So the chapters which are already you studied in 10th standard, those chapters will be selected in the bridge course, so that when you come for PUC first year, it becomes very easy to cope up those chapter. Right, same chapter sub plus some different level of examples we will discuss in these bridge course classes. So bridge course that is it fills the gap between a 10th pass students and entry of the PUC first year. So some concept which are related in PUC first year. So if you are discussing the bridge course class only, so that it becomes very easy for you when you go for PUC first year, right? So from chapters like coordinate geometry and trigonometry function, quadratic equation, and even arithmetic progression, statistics, and probability. So these are chapters you studied in 10th standard. The same chapter again you'll be studying in PUC first year, but little bit different level of example and higher level examples, that is of multiple choice questions also we'll be discussing. And in these chapters only we'll discuss some chapters for the bridge course, especially we'll concentrate coordinate geometry and trigonometry function, right? Later on, if another chapters also, for example, how to find log of a number, a partial fraction, so those we required in PUC first year, so those maybe chapters also we'll be discussing. First chapter is what coordinate geometry, which already studied in 10th standard, which is also called as what analytical geometry, right? So first we'll see what are the content we are studying this chapter, coordinate geometry, right? So in coordinate geometry, right, I told coordinate geometry, or it is also called as what analytical geometry. It is also called analytical geometry. So the content what I was studying in this chapter is just introduction part. What is the introduction part of coordinate geometry or analytical geometry, and distance formula, how to find distance between 2 points, that the concept you're studying, and section formula, that is a point R is dividing 2 points P and Q in some particular ratio M is 10. How to find the coordinate of that point, that we're discussing in section formula. Next is area of a triangle, how to find area of a triangle if ABC is a triangle whose vertices are x1, y1, x2, y2, and x3, y3, not base and height. If has given base and height, you can calculate area of triangle by saying half into base into height, right? But what I say is again how to find the area of triangle, that you are studying. And last new concept, that is called locus of a point. So these are the content we are studying in analytical geometry or coordinate geometry. So before going to the introduction part, first we'll see what do you mean by that coordinate geometry or analytical geometry. So the word geometry, right? Geo means what? Earth. Metry means what? Measurement. Measurement of an earth is said to be geometry. Then question comes, what is this? What is this coordinate geometry or analytical geometry? So coordinate geometry or analytical geometry is one of the branch of mathematics. It is one of the branch of mathematics which deals the study of geometry by using algebraic expression. So we are studying the geometrical shape. We are studying the geometrical shape by what? Algebraic expression. For example, right? For example, let us take the point. Right? This is point P of. So point you can represent in the ordered pair x comma y. Right? So this point is also geometrical shape. So you are studying the geometrical shape of this point by representing an algebraic expression. So we know that every point can be represented by an ordered pair, that is of the form x comma y, right? So we are replacing the geometrical shape by an algebraic expression, and we are studying the geometrical shape of that particular geometrical shape. So that branch is called as what? Coordinate geometry or analytical geometry, study of geometry by using algebraic expression, right? Even for example, if I take set of all the points, I'll get a line, straight line, right? So I can represent this straight line, I can represent by this straight line by an equation. So this is geometrical shape, this is geometrical shape. This I can represent in an equation. For example, I can take straight line equation is y equal to mx plus c. Y equal to mx plus c is a straight line equation. So this line is represented by an algebraic expression. Algebraic expression is what? It contains the term x by z, right, which is equal to some constant, that is said to be an algebraic expression. So this is an algebraic expression which represents the straight line. So study of this geometrical shape by using algebraic expression is called our analytical geometry or coordinate geometry. So this is a reason behind of that coordinate geometry studying. A scientist called Denis Riscard, he introduced this coordinate geometry or analytical geometry. Next, we'll see first thought what is the introduction part. So later on, we'll be seeing some examples related to that is some concept what we discuss in introduction part. And next thought, say important form that is distance formula, how to find the distance between 2 points, right? So introduction part, that is first we should know what do you mean by an coordinate system. That is if you take two perpendicular line intersect each other at an origin, that is said to be coordinate plane, or it is also called as what xy plane. So whenever two mutually perpendicular line intersect each other, right? Suppose if you are taking a horizontal line, right? A horizontal line, that is, and one more vertical line intersecting at the point origin, and coordinate of the origin is 0 comma 0. So this horizontal line is called as what x-axis, means x o x dash, x o x dash is called as what x-axis, and the one more line which is perpendicular to x-axis, that is called y-axis, that is y o y dash is called as what y-axis, right? So whenever two mutually perpendicular lines intersect each other, constitute an two-dimensional plane. So these are said to be coordinate axis, that is x o x dash and y o y dash are said to be coordinate axis, or else they are also called as what reference axis. In particular, x o x dash is called x axis, y o y dash is called what y axis. So whenever two mutually perpendicular lines intersect each other, that constitute a two-dimensional plane intersecting at the origin, and this divides into four quadrant, right? This divides into four quadrant. This should be first quadrant, second quadrant, third quadrant, and fourth quadrant. And how do you represent the point on positive x-axis? In particular, o x is positive x-axis, o x dash is negative x-axis, o y is positive y-axis, o y dash is negative y-axis, right? So how do you represent the point on x-axis? That is positive x-axis. So these are the points are x are positive. Suppose if I'm taking 1, 2, 3, 4, 5, 6, 7, right? So these are the x is positive on x-axis, and x is negative on negative x-axis. -1, -2, -3, -4, -5, and y is positive on positive y-axis, that is +1, +2, +3, +4, 5, 6, and y is negative on negative y-axis. So this is said to be coordinate plane or xy plane. The coordinate axis along with the origin is said to be coordinate plane, or is also called as what xy plane, which divides into four quadrant. So this is said to be first quadrant. First quadrant, where in this first quadrant both x is positive is greater than 0, as well as y is also positive, that is both x and y are positive in the first quadrant. Second quadrant, right? So this is your second quadrant. Second quadrant, in which x is negative and y is positive, that is the coordinate. How do you represent the coordinate point? That is x is negative and y is positive. This is the second quadrant. Third quadrant, both x is negative less than 0, less negative means less than 0, positive means greater than 0. X is negative and y is also negative. Both x is negative and y is also negative in the third quadrant. This is your fourth quadrant. Fourth quadrant, where x is positive, right? X is positive and y is negative, that is less than 0, plus comma minus, that is these are the signs associated in each different quadrant. That is the what are the sign taken by the points, right? So if we represent any point in general, right, in general, p of x comma y is any ordered any point. So that point is said to be Cartesian coordinate point. That is point is said to be Cartesian coordinate point representing the coordinate plane or xy plane. The point representing in the coordinate plane, that point is said to be Cartesian coordinate point. That is, first is said to be x coordinate and second said to be y coordinate. Always you are writing x comma y, which represent, it is x units along x axis and y units along y axis. It has gone. That point is said to what p of x comma y. And in general, definitely p of ordered pair, right, or Cartesian coordinate point, that is p of x comma y. If we represent in x and y, that is said to be Cartesian coordinate system, right? Cartesian coordinate system means the points are represented in the form of x comma y, right? So this is said to be coordinate plane or xy plane, and this point is said to be Cartesian coordinate system, that is represent that point in a coordinate plane, that is said to be Cartesian point. P of x comma y is not equal to P of y comma x, right? Because x comma y represent different point, y comma x also represent different point. So always writing first x coordinate then y coordinate. Even though if you're writing y comma x, that is different point. They are not what equal point. These two represent two distinct point. So P of x comma y is any point in the xy plane, right? And what is the perpendicular distance? What is the perpendicular distance from that point to the y-axis? So this point, right, this point is how much distance from x-axis, and this point is how much distance from y-axis. So if I'm dropping one perpendicular line from that point to the x-axis, so this, what does this perpendicular line distance indicates? What is perpendicular line indicates? So that perpendicular line distance indicates your what y coordinate. So this how much distance it is? It is parallel along y-axis. So whenever you're taking any point P of x comma y, that point is at what distance from x-axis? So this point is at a distance of y units from x-axis, and this point is distance from x units from y-axis. So this much distance, right? What is this distance? Is something about your y coordinate. What is y coordinate here? Y only, right? So if you're dropping a perpendicular line from that point to the x-axis, this perpendicular line distance is your y coordinate. Means the point P of x comma y is at a distance of y units from x-axis. And if you drop a perpendicular line to the y-axis, to perpendicular line to the y-axis, what does this perpendicular line distance indicate? This is nothing but how much distance it has moved along x-axis. So this distance is nothing but our x coordinate. So this is at a distance of x units from y-axis, right? So in general, if P of x comma y is any point, how much distance is there at that point from x-axis? So it is the distance at how much unit? Y units from x-axis and x units from y-axis. So in general, suppose let us take this point as, let us take this point as P of how much? 4 comma 3, right? 4 comma 3. So this much distance is your 3 units, and this much distance is your what? 4 units. So the point P of 4 comma 3 is a 3 units distance from x-axis and 4 units distance from y-axis. So this much is your 4 units. So this much is your 4 units, right? And this much is your how much unit is this? 3 units. So this distance from the point P to the x-axis is the distance of 3 units from the y-axis, right? So that's the first point you should remember. The point P of x comma y is at a distance of y units from x-axis, and it is the distance of x units from y-axis, right? If in general you are taken P of x comma y, and in particular in any ordered pair, if you take that, what number is it, that you have to write. And second point is that how do you represent a point on x-axis? How do you represent a point on x-axis? So this is the point, right? Let us take this the point of 4 comma 0. So this point is on x-axis. So this point is nothing but your 4 comma 0, right? And if I'm taking this point as, let us say this point as B, how do you represent the point on x-axis? So this point is nothing but 7 comma 0, right? So in general, any point on x-axis is given by, any point on x-axis is given by what? X comma 0. That is on x-axis, what is 0? Y coordinate z 0, right? So anywhere you go on x-axis, y coordinate 0. So this is 1 comma 0, 2 comma 0, 3 comma 0, 4 comma 0, 5 comma 0, 7 comma 0. And if you go on negative x-axis, minus 1 comma 0, minus 2 comma 0, minus 3 comma 0, minus 4 comma 0, minus 5 comma 0. So any point on x-axis is given by what? X comma 0. That is on x-axis, y coordinate is 0. in general, I can tell this y equal to 0, what it represents. Y equal to 0 represents the equation of x-axis, equation of x-axis. So drawing this x-axis or writing y equal to 0 is same. Means this line is represented by an algebraic expression called y equal to 0, which represents the equation of x-axis, right? And any point on y-axis is given by, any point on y-axis is given by what? 0 comma y, right? In general, any point on y-axis is given by 0 comma y, that is on y-axis what is 0? X is 0, that is on y-axis x is 0. Means what does x equal to 0 represents? What does x equal to 0 represent? X equal to 0 represent equation of y-axis, equation of y-axis. So any point on y-axis is given by 0 comma y, that is on y-axis x is 0. So x equal to 0 is the equation of y-axis, and y equal to 0 is the equation of x-axis. That's all. We are representing that line equation in the form of an line in the form of an equation. Just one example how we are representing x-axis and y-axis. Like that, we can give many different equations for a geometrical shape, right? It may be circle, it may be parabola, or it may be a line passing through origin. All those can be represented by an algebraic expression, and we are studying under a particular topic called as what? Coordinate geometry. Just it was an introduction part, that is what is coordinate geometry and what is a coordinate plane or xy plane. If you take three mutually perpendicular line intersect each other, that will constitute what? A three-dimensional plane. But in coordinate geometry, we are discussing about two-dimensional plane. If you're taking three-dimensional plane, means how do you represent the point? P of x comma y comma z, that is x units along x-axis, y units along y-axis, and z units along z-axis. But here we are taking a two-dimensional plane, that is x units along x-axis and y units along y-axis. So this is the point P of x comma y, right? How to plot the point? 4 comma 3. So x is equal to 4, means you have to move 4 units along x-axis, that is horizontally you have to move 4 units, and vertically you have to move 3 units. So this is the point 4 comma 3, right? That is what, how to represent the point in xy plane or two-dimensional plane. So, and one more concept is what, how to find the image, right? First was what are the signs of each point in all the quadrant, right? In first quadrant, second quadrant, third quadrant, and fourth quadrant. Second point, it was what are the point P of x and y is how much distance from the coordinate axis, that is how much distance this point P is from x-axis and y-axis. Second point. And third point, that is what are the equation of coordinate axis. Next is what is the image, what is the image of the point about x-axis and y-axis. Suppose if I'm taking, let us take the Cartesian coordinate system representing the point or coordinate plane or xy plane. So xy plane, x-axis and y-axis. What is the image? Suppose this is a point A, x1 comma y1 is any point. What is the image of this point about x-axis? Image means what? Its reflection, right? So this is acting as about x-axis, this is acting as a mirror. What will be its reflection? Means how much distance it has moved from how much distance this point is from x-axis. This is the distance of how much it is, y1 distance, right? So this is what, y1 distance, and this is of how much distance it is, x1 distance, right? So we are speaking what is the image of this point about x-axis. About x-axis means how much distance it has moved from that point to the x-axis. The same distance should be moved from that point, right? From this point to the downward part, that is this distance is same as nothing but what, y1, right? But let us call this as what, point as a dash. This is the image, right? This is the image. There is no change in x-axis remains same, right? So the image of this point about x-axis in fourth quadrant, it will be in fourth quadrant. What are the sign in fourth quadrant? X is positive and y is negative. Means the image of the point x1 comma y1 about x-axis, it will be x1 comma minus y1, because the y coordinate is negative in fourth quadrant. The image of this point about x-axis with this point present in first quadrant, its image about x-axis will be in fourth quadrant, means in fourth quadrant x is positive, y is negative. What is x here? X1, x1, and what is y? Y1 is minus y1. So this is the image of the point x1, y1 about the x-axis. And what about the y-axis? About the y-axis, so this much distance is x1. The same distance you should move, that is x1 distance, means there is no change in y, only change in x, right? So this point is in first quadrant. Its image about y-axis, it will be in which quadrant? In second quadrant. In second quadrant, let us call this as b dash. In second quadrant, x is negative, that is minus x1, and y is what? Positive, minus x1 comma y1. So this point is in first quadrant. Its image about y-axis, it will be in second quadrant. In second quadrant, x is negative and y is positive, that is minus x1 comma y1. These are the images of this particular point about x-axis and about y-axis. So this is the next concept, that is what is the image of that point with respect to x-axis and y-axis. And if I'm taking a point on x-axis, so for example, let us take this point only, right? So what is this point here? X1, right? X1 comma 0. So what will be its image about x-axis? You cannot tell. You should tell the image of the point x1 comma 0 about what? Y-axis. So this point is on positive x-axis. Its image, it will be in negative x-axis, that is minus x1 comma 0. That is the image of the point. The point is present on x-axis, positive x-axis. Its image, it will be in negative x-axis about y-axis. If the point I am taking on y-axis, its image will positive y-axis, its image will be negative y-axis, that is image of the point which is present on positive axis about what? X-axis, or on the x-axis it will be negative x-axis. So this is what one more small concept, that is what are the images of the point with respect to x-axis and y-axis, which is also called as what? Reference axis or coordinate axis. So when I say coordinate axis, means both x-axis as well as y-axis. In particular, x-axis, that is ax is, particular x-axis, y-axis ax is, right? Coordinate axis means what? Ax es, together x as well as y, that indicates, right? So let us discuss some examples related to this, just introduction part what we studied, that is coordinate system plane or xy plane, and representing the point in xy plane, that is Cartesian coordinate points, that is p of x and y, where first point is called x coordinate and second point is called what? Y coordinate, right? Note, right? So some of the note, that is the coordinate of the origin is what? 0 comma 0. The origin coordinate is 0 comma 0, and already we discussed any point on x-axis is given by x comma 0. Any point on x-axis is given by x comma 0. That is on x-axis, y coordinate is 0. That is on x-axis, y coordinate is 0, and equation of x-axis is y equal to 0. Equation of x-axis, y equal to 0, and any point on y-axis is given by what? 0 comma y, that is on y-axis x coordinate is 0, that is equation of x-axis is what? Y equal to 0. Sorry, equation of, it should be equation of y-axis, right? So y equal to 0, equation of x-axis y equal to 0, and equation of y-axis, right? Equation of y-axis is x equal to 0. Image of the point P of or A of x1 y1, image of this point x1 y1, this point is present in first quadrant, right? Its image in x-axis, it will be in fourth quadrant. In fourth quadrant, x is positive and y is negative, that is x1 comma minus y1. Image of the point x1 y1 in y-axis, this point is present in first quadrant. Its image in y-axis will be in second quadrant. Second quadrant, x is negative and y is positive. So there's a small note related to that introduction part, right? So let us discuss some examples related to that what we discussed in the introduction part of the coordinate geometry, right? Already I told it is a study of geometry by using algebraic expression. That is later on we'll be discussing, that is I told locus of a point, right? So that in that also we are representing some particular geometrical shape by an equation, right? And again, its continuation part, even in first year we have a chapter called straight line. To discuss that straight line chapter, we required all this concept, that is coordinate geometry. Its continuation part is only straight line, where we are studying the property of a straight line representing a geometrical shape, that is straight line by an equation, and we are studying various different, what are the different equations of line. First point, what you're studying, that line is what is the slope of a line, right? Later on we're discussing what are the different forms of a line and different equations of a line, and even what is the general equation of a straight line. How do we represent a general equation of a straight line which represents a straight line that can be replaced by an algebraic expression, right? That will be studying the chapter called straight line in your PUC first year. So just basic example, right? In which quadrant do the following points lie, right? In which quadrant these 2 points lie? First point, that is 3 comma minus 5. First point, that is 3 comma minus 5, lies in which quadrant? So here x is positive, right? X is positive and y is negative. X is positive, y is negative. Which quadrant it is? In fourth quadrant. So this point lies in fourth quadrant. Second, let us take second point as b. Second point is b, minus 4 comma 3. Minus 4 comma 3. Here x is negative and y is positive. X is negative and y is positive, we observe in second quadrant. So this point is present in second quadrant. Second quadrant. Third, that is minus 2 comma minus 1. Minus 2 comma minus 1. X is negative and y also negative, right? So this is negative, x point is negative and y point is also negative. So x is negative, y is also negative, we observe in third quadrant, right? Which is present in third quadrant. Last, x is positive and y is also positive, that is the point 4 comma 1, right? So here x is positive and even y is also positive. It comes in which quadrant? That is both are positive, it comes in first quadrant. So this point is present in first quadrant, right? So just simple example, that is you have to identify the points lies in which particular respective quadrant, either first quadrant, second quadrant, third quadrant, or fourth quadrant. The sign in first quadrant both x and y are positive. Second quadrant x is negative, y is positive. Third quadrant both x and y are negative. Fourth quadrant x is positive and y is negative. Second example, what is given here? X is less than 0. X is less than 0 means x is negative. Less than 0 means negative. Greater than 0 means positive. X is less than 0 and y is greater than 0. Where does the point minus x comma y lies in? In which quadrant it lies, right? So x is less than 0. X is less than 0. X is less than 0 means it is negative. Implies, right? Implies minus x, right? Already x is negative here. X is negative because x is less than 0. X is negative. Then what is minus of minus? Plus. If x is less than 0, minus x is greater than 0, right? Because negative into negative is what? Positive. X is negative means minus x is greater than 0. And even he has given, what he has given? Y is greater than 0, right? Then definitely y is also greater than 0. Means x is greater than 0 and y is also greater than 0. Means x is positive, right? Because he is asking what about this sign? Minus x and plus y lies. When x is negative, minus x is what? Positive. So minus x is positive and y is also positive. So minus x is positive, y is also positive, means both x and x coordinate and y coordinates are positive. That indicates that point. Which point? Minus x comma y lies in first quadrant. So if x less than 0, y greater than 0, then the point minus x comma y lies in which quadrant? First quadrant. First quadrant. Right? He has given particularly negative, x is less than 0, negative into negative, positive. So this minus x is positive, y is also positive. So both the coordinate, that is the x coordinate and y coordinate is positive, implies the point minus x comma y lies in first quadrant, right? So there's one more example related to identifying the point lies in which quadrant. Next example, A comma B belongs to Q3. Q3 means it's a quadrant 3. Q1, Q2, Q3, Q4. Q1 means quadrant 1, Q2 means quadrant 2, Q3 means quadrant 3, and Q4 means quadrant 4. If A comma B ordered pair or coordinate points, right? Coordinate, that is Cartesian coordinate points. Cartesian coordinate point we can represent in x comma y, or he has given the ordered pair as what? A comma B. A comma B belongs to Q3, right? Since, let us take, since the ordered pair A comma B belongs to Q3, A comma B belongs to Q3. Q3 means quadrant 3. Quadrant 3 means in third quadrant both are negative. Both are negative means what? A is less than 0 and B is also less than 0. Right? A is less than 0 and B is also less than 0 because the point A comma B lies in third quadrant. So this symbol stands for belongs to, and this symbol stands for does not belongs to. The point belongs to and the point does not belongs to. Okay, but we want the point minus a comma minus b lies in which quadrant? If a is less than 0, implies minus a is definitely greater than 0. Minus a is definitely greater than 0, and b is also less than 0. B is also less than 0. Then minus b is also greater than 0. Right? Minus b also greater than 0. So negative, so minus a is positive, minus b is also positive, means first sign is positive, second sign is also positive, implies the point minus a comma minus b lies in which quadrant? First quadrant, right? Both are positive. If a is less than 0 and b is less than 0, minus a is greater than 0 and minus b is also greater than 0, implies minus a comma minus b, the point lies in first quadrant, lies in first quadrant. Right? So just simple example related to identifying the point lies in which quadrant. Next one, what are the distance of the following points from the coordinate axis? Coordinate axis means what? X as well as y axis. X as well as y axis, right? Coordinate axis means both x as well as y. How much distance this point is there from x-axis and how much distance this point is there from y-axis. I told the point P is at a distance of y units from x-axis and it is a distance of x units from y-axis, right? So what is the y coordinate is 3, means this point is at a distance of 3 units from x-axis, and what is the x coordinate here? 4. So this point is a distance of 4 units from y-axis, right? I told just if you take a point 4 comma 3, right? First point is what? 4 comma 3. So this much distance is your, how much it is? 4 units, and this is your 3 units, right? So this is your 3 units and this is your what? 4 units. And if you draw same parallel, this is also 4 units, this is what? 3 units. So this point is a distance of 3 units from x-axis and 4 units from y-axis, right? So the y coordinate gives the perpendicular distance from x-axis, x coordinate gives the perpendicular distance from y-axis. So this point is a distance of 3 units from x-axis and 4 units from y-axis. And what about this point minus 3 comma 5, right? What is its y coordinate? 5. So this point is a distance of 5 units from x-axis and not minus 3 units, right? Not minus 3 units from the y-axis, because distance is always measured in terms of positive. So this point is a distance of 3 units from y-axis and 5 units from x-axis. And this point is a distance of 2 units from x-axis and 5 units from y-axis, right? Already we discussed how if you drop a perpendicular line, what are this perpendicular distance from its coordinate axis, right? So let us write the solution. First one, the point the point 4 comma 3 is at a distance of 3 units from x-axis and 4 units from y-axis. Second one, the point minus 3 comma 5 is at a distance of 5 units from x-axis and 3 units from y-axis, right? So third one you can write by yourself. This is distance of 2 units from x-axis and 5 units from y-axis, right? Let us go for next question. Simple. Already I told how to plot the points in xy plane or coordinate planes. Plot the points capital A, capital B, capital C, and capital D in the xy plane. That is, two perpendicular lines intersect each other. That is, to be xy plane or two-dimensional plane or coordinate plane. Y O Y dash, X O X dash. Origin, right? So these are positive values of x, 1 2 3 4 5 6 7, -1 -2 -3 -4 -5, +1 2 3 4 5 6. First one, capital A 2 comma 3 means you have to move horizontally 2 units along x-axis to 2 units along x-axis and vertically 3 units along y-axis, 3 units along y-axis. This is the point capital A 2 comma 3. That is the point capital A 2 comma 3. So this distance is 2 units and this is 3 units. This is the point 2 comma 3. Second, -1 comma 2. So you have to move 1 units along negative x-axis because the sign is -1. So this is 1 unit along negative x-axis and positive y-axis along positive axis 2 units you have to move. This is 2 units along positive y-axis. This is your capital B point, I can tell. -1 comma 2, right? -1 comma 2. This is x is -1 and what is y? +2. The point -1 comma 2 lies in second quadrant. Third one, -3 and -2. -3 and -2. You have to move 3 units along negative x-axis because it is minus. But horizontally, you have to move 3 units. 3 units along negative x-axis, and again you have to move 3 units along, not 3, 2 units along negative y-axis, right? So not along vertically, not along positive x-axis, vertically along negative x-axis. So this is the point. Let us call this point as what? C. -3 comma -2, right? This is what you are representing, the point which is present in third quadrant. 3 units along negative x-axis and 2 units along positive negative y-axis. Last, 4 comma -2, 4 units along x-axis, positive x-axis, 4 units along positive x-axis and 2 units along negative y-axis, 2 units along negative y-axis. So this is the point D, that is 4 comma -2, 4 comma -2. So this is what, just we plot the point, how to directly plot the points in a xy plane. Directly 5 comma 6, 5 comma 6 means this is 5 and this is 6. So this point is on 5 comma 6 and we can take any representing for the test point as p 5 comma 6, right? So this simple example how to plot the points. Next, same thing, mark the points capital A, capital B on the plane, find the reflection, right? Reflection or image. Okay, just to try to solve this example, sixth and seventh one, right? So seventh also, write the images in the y-axis or images of this point in y-axis, and images of this point, point A 3 and -4 in x-axis, and -4 and 2 in what y-axis. So this point is in which quadrant? X is positive and y is negative. So this is 3 comma -4. Its image in x-axis will be in first quadrant, right? So x is positive and y is negative, it is in fourth quadrant. Its image it is in first quadrant, that is 3 comma 4, right? And -4 comma 2, x is negative, y is positive. This is the point B, -4 comma 2, x is negative, y is positive. Its image in y-axis, right? Its image in y-axis selling, and that of B in y-axis. It is in first quadrant, that is 4 comma 2, right? So just try to solve this example. Next class we'll be discussing this example, and even the next form, that is called distance form, right? So try to solve these two example, plotting the points and finding the its image, right? Thank you, students. Tomorrow we will continue the class. Thank you.